Hello everyone, welcome to this new session. So where we are continuing with the concepts of mathematics 2 for first module, that is vector calculus. So till now we had discussed some of the concepts related to gradients, directional derivatives, curl and divergences and so on, and we have discussed problems related to that as well. Detailed explanation we have done till now. So again, those who have not watched those videos, already 5 videos are uploaded in this playlist before this video, so please go and watch it, those who are new to this video now. And those who are new to this channel, please subscribe to our channel and keep hit the notification bell to get the latest notifications. So we are going to continue with the concepts of first module itself. There are many more concepts in the first chapter of this module, that is vector differentiation. So one more concept is physical interpretation of divergence and curl. Okay, where in this we are having two conditions, that is solenoidal condition and irrotational condition. Okay, let us see what these two conditions state and how it should be represented. Let us see that one by one. Okay, first is solenoidal. So in solenoidal, if the vector f represents the velocity of a fluid in a fluid flow, okay, then divergence of this f vector represents the rate of fluid flow through the unit volume. Okay, a vector f is said to be solenoidal if the condition satisfied is like this, that is divergence of any f vector given in the particular question. They will be giving you an f vector. If its divergence is equal to 0, then we can say that it is solenoidal. Okay, it is clear, right? In the question they would be giving you an f vector. Okay, we should be taking its divergence, and after you take its divergence, the resultant, if you get the answer as 0, then we can say that the condition is satisfied, that is it is solenoidal. Okay, similarly we have one more condition, that is irrotational. Curl means rotation. The curl of velocity vector is twice the angular velocity of w of rotation. The vector f is said to be irrotational if the curl of f vector is equal to 0. Okay, for solenoidal, what's the condition? An f vector would be given. If divergence of that f vector is equal to 0, then it is said that it is solenoidal. If curl of that f vector is equal to 0, then we can say that the condition is irrotational and it is satisfied. Okay, under irrotational conditions we have some notes here which you need to be knowing. That is, note 1, irrotational vector field is also called as conservative field or potential field. Okay, this is one thing. Next, if f vector is irrotational, then there exists a scalar function phi such that the gradient del phi is equal to f vector. Okay, if f vector is irrotational, then we have one more condition which satisfies, that is del phi is equal to f vector, and that phi is called as scalar potential of f vector or scalar point function of that f vector. Okay, this comes under only the irrotational condition. So these were the things which you need to be required for a physical interpretation of divergence and curl with respect to solenoidal and irrotational conditions. Again, I'll summarize. If an f vector would be given, if you take its divergence and the resultant, if you get it as 0, then the condition is said to be solenoidal. Similarly, for that f vector, if you take the curl of f vector and the resultant, if you get it as 0 vector, then the condition is said to be irrotational in nature. Okay, so this was the physical interpretation of solenoidal nature and irrotational nature with respect to the divergence and curl. Okay, so related to this, let us solve few problems and conclude this topic. Okay, now let us solve one problem which is important one. Let us get to that question now. So this is that first question. Show that they have given one f vector here, that is f vector is equal to xi cap plus yj cap, the whole divided by x square plus y square. Okay, so this is the f vector given here. We should be showing that these f vector are both solenoidal as well as irrotational. Okay, how to solve it I've told you. If first they have given an f vector, we should be taking first the divergence of f vector. If it is equal to 0, then it is solenoidal. We should be getting 0 because they have told us to prove it. Okay, so this, if you take its divergence as well as curl, you should be getting our answer as 0. Okay, now let us check whether we get our answer as 0 or not. Okay, let us check it now. First, take the divergence of this vector. Divergence of f vector. That is equal to dot product, that is del dot f vector, right? So if you take its divergence, So since the f vector given here is of the form u by v, that is it is of the division form, so we should be using the u by v rule, okay, which says that v into differentiation of u minus u into differentiation of v, the whole divided by the square of the denominator. Okay, so this is u by v rule, hope you might be knowing it. Okay, that we are going to use it here, and let us solve for this divergence of f. Okay, first write the denominator as it is, that is x square plus y square the whole square. Okay, now denominator first x square plus y square v du, right, v du, so v is the denominator, so we write it as it is, x square plus y square into du, that is differentiation of numerator. But in this case it is not only differentiation, we should be doing the partial differentiation with respect to the divergence, right? Since they have told us to find the divergence, so here the numerator is xi cap plus yj cap. So if you take the divergence of this, only this part here, that is xi cap plus yj cap, what we would be getting our answer as, these two are constants, so if you take its divergence, so I'll solve it here, the xi cap plus yj cap, if you take its divergence, the formula is dou, if you take these two are constants, dou a1 by dou x and plus dou a2 by dou y, right? So dou by dou x, here we have only one x term, so if we take its differentiation it is 1, so we would be getting 1, plus here we have y, so if you take its differentiation with respect to y, it is again 1, so 1 plus 1 is equal to 2, right? So here we would be getting, in place of numerator, after differentiation we should be writing 2 here, okay, since we are taking the divergence. Similarly, minus u as it is, that is numerator as it is, xi cap plus yj cap into the differentiation of denominator, that is x square plus y square, okay. Again, this is a since we cannot take its divergence, since it is a scalar function, right? So what we could be doing is, we could be directly taking the gradient of this by saying this term as phi is equal to x square plus y square, and if you take its differentiation, what we would be getting, partial differentiation with respect to x, we would be getting 2x I cap, with respect to y we would be getting 2y j cap, okay, since it is a scalar function. So hope it is clear. This is the first step. In this way you should be writing it. Okay, now let us continue. So these two are getting multiplied, so del dot f vector is equal to 2 times x square plus y square. Now do this multiplication part, minus of xi cap into 2xi cap, that is I cap is 1, so x into 2x is 2x square, so xi cap into 2y j cap, so I cap into j cap, those two are different unit vectors, so the resultant would be, product is 0, so these two terms also would be 0, so this is not possible. Now y j cap, and this also is not possible because we have I and j cap, these two are different vectors, so it is 0, so y j cap into 2y j cap, so j cap is 1, y into 2y is 2y square, okay, whole divided by x square plus y square the whole square, okay. Now solve it, multiply 2x square plus 2y square minus 2x square minus into plus minus 2y square, the whole divided by x square plus y square the whole square. Now 2x square minus 2x square gets cancelled, 2y square minus 2y square gets cancelled, we would be remaining with 0 divided by x square plus y square the whole square, right? Now 0 divided by anything is 0, right? You know, you would be knowing it, so we could conclude by saying that divergence of f vector, that is del dot f, is equal to 0. So we can say that it is solenoidal. Okay, this is a simple way to solve this problem. Hope it is clear. So now let us check for irrotational condition, that is we should be taking the curl of f vector, that is del cross f vector. Okay, let us take that and see whether we get our answer or not. That is, first I cap, j cap, k cap in the first column. Second, we should be writing partial derivatives, dou by dou x Next we should be writing the coefficients of f vector. That is, if you split this f vector and write it as x divided by x square plus y square into I cap plus y divided by x square plus y square into j cap. So k cap term is not there here and one more term is not there, so plus 0, so k cap. Okay, so these are the coefficients here. These two, x divided by x square plus y square, y divided by x square plus y square, and 0. Okay, now for this, solve for curl and let us see whether we get 0 or not. Okay, first I cap into dou by dou I into 0 is 0, dou by dou z into this term. So here if you see here, we don't have any z term, so again it is 0, minus j cap into these two terms, dou by dou x into 0 is 0, dou by dou z into this term. Here if you see here, we don't have any z term, so again it is 0, plus k cap into, now we are not getting 0. If you see here carefully, dou by dou x into y divided by x square plus y square. Again we should be taking the u by v rule in the condition again, and take the u by v rule. That is, first write the denominator square, x square plus y square the whole square, and do the partial differentiation in the numerator part. That is, x square plus y square denominator as it is into the differentiation of numerator partially with respect to x. Okay, so we don't have any x term, so that is equal to 0 minus numerator as it is y into differentiation of denominator with respect to x. Again we don't have x term here, so this goes, and differentiation of x square is 2x. Okay, so this whole term minus dou by dou I into this term. Again this is of the form u by v rule, so again write the denominator square, x square plus y square the whole square. So denominator as it is, x square plus y square into differentiation of numerator with respect to y. So here we don't have any y term here, so it is 0, minus numerator as it is, x into differentiation of denominator with respect to y. So here we don't have y term, this becomes 0, so y square is, differentiation is 2y. Okay, so here these two are 0, so let us solve for this part only now. 0 I cap plus 0 j cap, and let us see whether we get this term as 0 or not. Okay, plus k cap into, now here x square plus y square into 0 and x square plus y square into 0 is 0 only because it is multiplied by 0. So here we are left with minus 2xy divided by x square plus y square the whole square, minus of, here again we have minus 2xy divided by x square plus y square the whole square, right? So here it is minus into minus is plus, right? So we would be getting k cap into minus 2xy minus minus plus 2xy, denominators are common, x square plus y square the whole square, and if you cancel these two we would be getting 0 in the numerator, so 0 divided by anything is 0, so we would be getting our answer as 0 I cap plus 0 j cap plus 0 k cap, that is equal to 0 vector, right? So hope it's clear how we got this. So again we can prove that del cross f is equal to 0, then we can say that the condition is irrotational. Okay, it is satisfied. So we have proved that in this problem the f vector is both solenoidal as well as irrotational. Since divergence of f we got it as 0, also the curl of f we got it as 0 while solving this problem. Okay, so hope it is clear how to solve for solenoidal and irrotational conditions. So that's all for this video, guys. I plan to solve 2 problems, but the other problem is a bit lengthier one that I'm going to discuss in the next video. So I'm concluding this video now. Let us see some other problems in the next video and try to solve it and try to understand this condition. Okay, so that's all for this video, guys. Thank you.